to do just a short one. All right, so we're going to use the example of P. I'm making this up. This is totally not an actual molecule, I don't think, so don't go looking it up. pH2 Cl. Let's do that. pH2Cl. Okay? All right. So with this idea, all right, you would still be approaching it like we did with NAS. And it was the first thing that you always have to do is pick which one is going to be the central atom. So looking at those three options, which one is going to go in the center? P. Yeah, it's P. Because we're not going to choose hydrogen, and we're not going to choose somebody from group 17, correct? So when we have, now that we've figured that part out, the next step is go to the basics of electron dot notation, right? So what we were really doing for, especially our ionic thing with the arrows and stuff like that. And so what you start out with is just draw each one with their electron dot notation. So P was in group 15, so it had 5 dots on it. H is in group 1, so they each have 1 dot on them, right? So we're going to just draw H with a dot. Notice I put the dot wherever I want to put the dot. It doesn't always have to go on the top, all right? That was also bothering some people yesterday, all right? So there are 2 of those, so I'm just going to draw them so I have 2 of them. All right, and then I'm going to have Cl. Cl was in group 17, right? 17 meaning it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Okay. All right, at this step, you have 2 options. You can either go straight over to the drawing because you know who's central, and you just make your bonds on the single dots, or take a second for yourself to connect your dots, right? So the whole idea of a bond is everybody is trying to get to 8, right? That was our ultimate goal. So at the very end, it's going to be really important that you're checking each individual atom for its octet, okay? But on this step, what we're trying to do is you're just trying to connect your dots, right? Are we ever going to connect to something that has double dots? No, right? It's already full. It's kind of like you hold somebody's hand, you only hold one of their hands. Sometimes it's awkward. They like grab your hand and they're holding it in both of them like that. You're like, all right, like this one. It's fine, right? So you never hold 2 hands anyway. So just like that, hold one hand, that's it. So each of these electrons are only going to connect their single dots. So we already see phosphorus has how many dots to connect to? 3, right? Chlorine, we're just going to connect our single dots. Had 1 right there. Hydrogen has 1 right here. This hydrogen has 1 right here. So this right here is kind of telling you what it's going to look like. That's where the lines are going to be. So what you're going to do is you're going to pretend you have a little rope and you're going to pull it in tight, and they're all going to come together and make this perfect molecule. So you're going to have your phosphorus in the center. You're still going to draw it the way that it looked originally, right? Central atoms, draw them exactly the same. What that will take care of is this. That's what a lot of people are forgetting, is those lone pairs that were originally there, right? That's what the problem I think has been. Then you're going to pull in the rope. You're going to swing it in. So we're going to have, okay, this is going to turn into a bond to chlorine. Chlorine had these 6 extra electrons on the outside. That's what it had originally. It keeps those, okay? This one is going to connect to our hydrogen. Does hydrogen have any lone pairs or anything? No, right? Hydrogen bonds 1 and done, right? And then it's going to connect to this hydrogen, so we're going to have another line to that hydrogen. That's your molecule right there, okay? And what you're going to start seeing today, if we have time, I'd like to go over how to start recognizing your, how many of you guys actually did most of that page, the single page? All right, so we're still going to be working on it. What I'm going to have you do is, because I'd like to use it right now, and this way we're recording it, and then we'll reapproach it on Monday. But take this page and flip it over real quick. I'm going to point to something. There's extra information on here, okay? It's really tiny, and I'm sorry. On Monday, I will give you, I have the copies over there, but since we're missing as many people as we are, let's just wait till Monday for the new stuff, okay? But you have your shapes right here, right? So looking at these, it's kind of hard to match up what we just drew, right? Like you're like, I think it's something that has like 3 lines, maybe, possibly, but if you look, this one has 3 and this one has 3. So then you're wondering, okay, well, which one is it, right? So that's where I want to point to the complicated, tiny looking one right here, okay? So I know it's going to be really hard to see. I'm so sorry. I'm going to focus in on only one column on here, okay? Here are your names. You can kind of match them up to the pictures on the left. You're only responsible for knowing through bent, okay? So you should know these 5, the ones that were in this picture over here, okay? The ones below, those are from AP, all right? So you might see them, and if you do, cool. All right, these pictures, I think they're tough to see. So personally, I wouldn't even look at that. I would swing over here. Here's a couple examples, but even those are tough to see. This is the column that I want you guys focusing in on, and it says type of molecule. This is another notation on how we can kind of write out what the different shapes are. It's called ABE. Some people do ABX, okay? We're going to do ABE because that's what's on our little chart here. So just write this at the top of that, A, B, E. And I'm just gonna write down what each of these stand for, okay? A, this is your central atom. Okay, so whoever you chose to be the center, that's your central atom. So everything that we're looking at now is related to central atom. I'll use the CA, like that. That's what I'm gonna write over here. All right, so B. B is bond areas on central atom. Bond areas on central atom. Now, what does that mean? That means if you have a double bond, that counts as 1 bond area, all right? You don't count it as 2 bonds. So I could say number of bonds, but I definitely saw when I said that the first time, people were like, well, it's double bond, there's triple bond, right? It only counts as 1 bonded area, if that makes sense. So how many lines are kind of coming from it? All right. E. E is number of lone pairs. So pairs, not electrons. Number of lone pairs on central atom. So everything is related to that central atom. Okay? So the one that we just drew, right? We had, I'll just put mine up here. You guys can look at your chart with me. P, and then we had H, H, Cl. Okay. Using this idea. Okay. Central atom. So we would put an A. You don't have to draw it, by the way. You can just kind of look at it with me. All right. B. How many bonded areas are on my central atom right here? How many? 3, right. We have 1 area, 2 area, 3 area. So we're going to say B little 3. How about number of lone pairs on my central atom? How many lone pairs are on P? Just 1 lone pair, exactly. We have 1 little spot right there, so we're going to say E. All right, so A, B, 3, E. Look down your little list. Which shape is that? Trigonal pyramidal. Okay. So what I want to point out, and this is what you guys are going to be doing in the lab, is you're going to get to see the 3-dimensional stuff of this, right? Because this is very flat, and so you kind of picture it like this, right? You kind of picture it as like this thing that's just like this, and if I pick it up, it's going to look like this and whatever. What it actually looks like, you can kind of see it over here. Do you see that this one sticks up like a pyramid, right? Trigonal pyramidal. It just kind of sits like that, okay? And so I want you guys to start noticing that. So anybody who did finish most of the drawings yesterday, I encourage you to go through now and try to figure out what your shapes are. That's the next step, okay? So, but I'm going to give you guys about 10 minutes of work time to kind of, to ask me questions or to help each other out. You can also do some of the ionic ones at the bottom, but definitely practice the covalent. We are going to take a small quiz, okay? I think it's like 4 or 5 questions, and some of them are multiple choice, so it's not bad. Just to kind of finish out the week and make sure that we did each of the bonding, and then we'll have stuff for Monday, okay? So test over this whole chapter is going to be next Friday. Just heads up, Okay? All right, cool. All right, so go ahead and work